Alright, this is 6162 calculator part 2, but this time we're using the calculator to find x, or find z. Really what we're doing is finding the critical value. Alright, so down here, we're trying to find z. We don't have z. We have the probability, we have the percentage, we have the area, but we don't have z. So, when I look over on my calculator, and I go second distribution, do you see any command there that's like the reverse of doing the normal? Like number 3 here, which is inverse normal? That's what we're going to use. And the area we're plugging in is 65% or 0.65. And that is the z value that corresponds to 65%. There's a problem though. Do you see how this is drawn? I started counting my area all the way to the left. Alright? That's how z inverse works. Okay, let's get more specific. If I drew this top picture and I asked what is z, this area is asking the area about the right. That's not what inverse z does. Inverse z starts counting all the way to the left instead. So is there some way that I can make a picture that has the same z, but I shade the other side? Yeah. I'm just going to look at the complement area, the complement percent. So I wanted to know where the top 20% starts is the same as where does the bottom 80% end. Do you see it as just 100 minus 20% to get this picture? So this is what I need to plug in. Now, drawing another normal curve, you might have a picture that's an in-between picture. Let's say we want to know where the middle 50% is, and we don't know what Z1 is, and we don't know what Z2 is. Now we're going to have to do something to kind of break this up. So let me ask you the question. If the middle is 50%, how much is on the outsides? The other half of that. So the other 50% is here and here. So in other words, this is 25%, isn't it? And this is 25%, isn't it? So if I want to find these z values, I want to get inverse norm of 0.25 for this guy. Inverse norm 0.25. And to get this value, do you see how we're looking at the top 25? So I could think of the complement and get the bottom 75. So inverse norm of 0.75. Now, there's some things we can do with symmetry, and we'll see that one's negative, one's positive. Similarly, if you're doing applied problems, you can use the same syntax, comma, x, comma, sigma, to convert it to the applied problem. And I'll do an example like that on the next video. But what I want you to get out of this is, inverse norm does not count the right, it counts everything from the left up to an ending point. So if you're given something like this, you have to convert it to that to get your value.